Hey guys, welcome back to another video. In this video, we will learn how large language models like ChatGPT and Gemini actually read the text. Before an LLM can understand anything we type to it, it first needs to convert it into something it can process. This process is known as tokenization. So let's see how this actually works. As humans, we naturally read words and sentences. For example, when we see hello, how are you? We immediately understand its meaning. But an LLM doesn't read text like we do. It only understands numbers. So before the sentence reaches the model, it first needs to be converted into smaller units called tokens, and each token is assigned a numerical ID. This conversion is the first step before the model can process any text. So what exactly is a token? So token is a small piece of text that an AI model can process. It can be an entire word, a letter, or a subword. So for example, we can break I love learning AI into I love learning AI. This is an example of a word-based tokenization. So here each word is characterized as a token. Again, you can also have like character-based tokenization where each character would be a token, or subword tokenization where you break a larger word into smaller chunks like learning can be broken into learn plus ing. So each of these pieces, as we can see in the example, is a part of a token. So now what is tokenization? So tokenization is basically the process of breaking the text into smaller pieces or tokens. So there are three major techniques of tokenization, that is word, character, and subword tokenization. We will be looking at them one by one. So firstly, we have word tokenization. So word tokenization basically means splitting the sentence word on the basis of words. So for example, we have a sentence, machine learning is fascinating. We can break it into machine learning is fascinating, resulting in four tokens. So this approach is decent, but it has a few limitations, and the major one is out of vocabulary word. So suppose the user types a word which is not in the vocabulary or is a misspelled word from the user. Then the tokenizer replaces it with a UNK or an unknown token, which results in the model losing important information. So to counter this, there was a character-based tokenization. So here we break the entire sentence into character basis. So for example, if we have an input of E, we break it into separate alphabets, which act as tokens in this case. So this method, even though it helps in reducing out of vocabulary, but it also has a few limitations. Like firstly, the sequence increases a lot. So the model has to spend a lot of time processing the text and results in slower response time, and also the it becomes very difficult for the model to actually understand meaning of words, as breaking down into characters doesn't really help the model in understanding the meaning. Hope it makes some sense. So now we are going to study about subword tokenization, which is majorly used in all of the LLMs for breaking down words. So subword tokenization basically means splitting the text into smaller meaningful pieces for the word, not exactly taking complete words, but splitting the larger ones into smaller chunks. The biggest advantage of this method is that it reduces out of vocabulary words. So let's see a few examples. Like play is a large word which is broken down to play plus ing. Similarly, unbelievable gets broken down into unbelieve and able. So the biggest advantage of this method is that it helps avoid out of vocabulary. Because suppose the user writes a word which is not present in the vocabulary, then there are very rare chances that the entire word is not present. So suppose the user writes unimaginable. and that was not in the vocabulary. But there are chances that un or imagine or able, a few of them might be present in the dictionary. So by this, the LLM is actually able to understand what the word was instead of treating it as an unknown token. So here is a comparison of all the three methods. So as you can see, out of vocabulary words gets handled in character level and subword tokenization and not in word waste. And subword tokenization and word tokenization don't have very largest sequences. Vocabulary size is the smallest in character tokenization, obviously because you have like 26 alphabets and you can see which approach is used. So all of these methods have a few pros and cons, but modern LLMs generally choose subword tokenization because it offers the best overall balance. So this brings us to an important part. That is, how does the tokenizer know that laying should be split into play plus ing or unbelievable should be split into un plus believe plus able? The answer to that is that the tokenization learns these words automatically by analyzing millions of books and documents. It identifies the most frequently occurring text pieces and builds a vocabulary from them. For this, algorithms are used such as byte pair encoding, word piece, and sentence piece. In this video, we focused on the concept of tokenization, and in the next video, we will look at one of these algorithms in detail. That's all for this video. I hope you now have a clear understanding of what tokenization is and why modern LLMs use subword tokenization. If you like the video, make sure to like, comment, and subscribe, and let me know how I can improve my videos in the future.